Hello and welcome again to the Calculus 3208 final exam review presented by CDLI. And today we're going to be talking about, still on the topic of derivatives, specifically we're going to be finding the equations of tangent and something called normal lines. Let's be very clear now. It's a very common confusion between folks. When they see equation of a tangent line, they sometimes think slope of a tangent and vice versa. But we should be clear about the difference between the slope of a tangent and the equation of a tangent. So we've already seen how to find slopes of tangent lines. In this session, we'll find the entire equation for that particular line. All right, let's get rolling. So some of the key ideas that we're going to look at here, we're going to talk about a review of some linear functions and their properties. So very important stuff, but until you hit this course, many of you probably haven't dealt a whole lot with it since grade 10. So we're going to make sure we remember a few important things about linear functions. We're going to learn how to find the equation of a tangent line and how to find the equation of a normal line. And then we'll do some examples, and then that'll be it. All right, so let's get right down to business. First thing we got to do is remember a few ideas about linear functions that we covered way back in Math 1201. The first one is, how do we find the slope of a straight line? Well, if you have 2 points, x1, y1, and x2, y2, we just plug them into that little formula. So that's old hat for everybody, I hope. But let's just remember, so this is for 2 points, x1, y1, and x2, y2, and then we use that formula. And a couple of things about slopes that we have to remember is that if we have 2 different lines but they're parallel, they will have equal slopes. So if I have line 1 and line 2, then m1 equals m2. They have the same slope if they are parallel. But if they are perpendicular, and this is also very important, perpendicular lines have negative reciprocal slopes. So if line 1, for instance, has a slope of 3 and line 2 is perpendicular to it, then its slope would be minus 1/3, etc. Okay, when it comes to the equation of a line, probably the most commonly used version of the equation of a line is y equals mx plus b. And some folks actually use that version of the equation when finding the equation of a tangent or a normal line. We're going to do that a little bit differently. There's kind of a tidier and quicker way to get that done here. But in order to do it, we have to remember something called the slope point form of the equation of a line. And this is something that you should also have studied extensively in Math 1201. So basically, if you have a line that has a slope of m, and you know that it passes through a point with coordinates x1, y1, then you can find the equation of the line by simply filling that business into this equation. So the coordinates x1 and y1 go here, the slope goes there, and it's just a different form of the equation that we know for the line. So that's a handy tool for us to have as we go forward. So we're going to take that form of the equation of a line, and we're going to apply some of the things we know about tangent lines, first of all, to figure out how all that works. So let's take a look, first of all, at what a tangent and a normal line look like. A tangent line is actually, as we've seen before, like the blue line that we see on this particular graph that runs this way. That blue line right there is a tangent because it touches the curve at this point, but it doesn't actually cross through it. And a normal line is a line that goes through the same point that we call the point of tangency right here. And in math words, normal means perpendicular. So a normal line is just a line perpendicular to the tangent that also goes through the point of tangency. So one thing we could say for certain, because we know about the slopes of perpendicular lines and how they're related, we could say that the slope of the normal line is going to be the negative reciprocal of the slope of the tangent line. Okay? That's an important point as well. So 2 things we've got to keep in mind as we jump into this: the point-slope form of the equation of a line and the relationship between the slopes of perpendicular lines. Okay, so let's look at how we figure out the equation of a tangent. So here is the point-slope form again. And remember, all we need to know is a point on a line and the slope of the line. And if x1, y1 is a point on the line, and we say that we're going to go through the line at a point of tangency where x equals a, then x1 will be a and y1 will be f of a. So the x and y coordinates at the point of tangency. And the slope of the tangent is something that we spent a great deal talking about in this course, and that is the value of the derivative f prime evaluated at a. So we've got f prime of a, and f of a can all give us important information that we fill into that formula to help us get the equation of a tangent line. And this is sort of a shortcut version of how we figure out the equation of a tangent line. We just take the value of the derivative at the point, multiply by the variable x minus the x-coordinate at the point of tangency, and we add the y-coordinate, or the value of f, at the point of tangency. So if we wanted to take that formula and by the same process sort of surmise what we would have to do to get the equation of a normal line, there's really only going to be one thing that's different, because both lines go through the same point, so all of this stuff should be the same. It's the slope that's different, but it is related to the slope of the tangent. So if we look at the equation of a normal line, it all lines up the same way, except instead of just having f prime of a for our slope, we have to take the negative reciprocal of it. And so therefore, if we wanted to write a formulaic way to look at the equation of a normal line, then it would look like this. And pardon my typo right here, that word should say normal. Wow. All these typos, you might start to think things are abnormal, but no. That word should say normal line right there. Sorry about that. All right, so let's jump into an example. It says find the equations of the normal and the tangent lines for the curve f of x equals 3x squared plus 2 at the point where x equals 1. So the first thing we need to make a note of, and I'm just going to scribble it over here on the right-hand side, I just want to make a note of all the stuff I need to know. In order to get the equation of a line, I need to get a point. And for us, that's going to be the point of tangency, where x equals 1, and f of 1 is going to be the y-coordinate, based on the function f of x that we have. So we have our point, and we're also going to need a slope. And to get a slope for the tangent, we're going to say it's just f prime of 1. Oops, that doesn't look like a 1. And for the normal, it's going to be f prime of, it's going to be f prime of 1, but we want the negative reciprocal of that. Negative 1 over f prime of 1. All right, so those are the kind of things that we're looking for. As long as we have the coordinates of that point and those two slopes, we should be able to get both of those. So the first thing we want to get is, well, we know the x-coordinate. We need the y-coordinate for the point. So for our point of tangency, when x equals 1, we're going to find f of 1, and that will be 3 by 1 squared plus 2, giving us a total of 5. So our point of tangency has coordinates of 1, 5. Good stuff to know. The next thing we're going to need to get is we're going to need to get the derivative of this function so that we can find the slopes of the tangent and the normal. So we need to find f prime at 1. So you can either find f prime of x and then fill it in after, or you can just get f prime of 1 right away. I think I'll do it that way this time. So let's get f prime of 1. So that's going to be the limit as h approaches 0 of f of x plus h, in this case where x is 1, so 1 plus h, minus f of x, which is f of 1, which we're lucky we just found, all divided by h. So this is the limit as h approaches 0 of f of 1 plus h will be 3 outside of 1 plus h squared plus 2. And then we have to subtract f of 1, which we just figured out was 5. And then that will all be divided by h. Okay, so I'm going to do this expansion right here real quickly. So, oh, I said x there again. I tend to write hx's when I mean to write h's. I'm not sure why that is. So we've got the limit as h approaches 0 again. And for this business right here, that's h squared plus 2h plus 1. Multiply all that by 3, and we have 3h squared plus 6h plus 3. And then outside here, 2 minus 5 is negative 3. And that's all over h. Negative 3 and positive 3 are gone. So what we're left with is a couple of things here with a common factor of h, which is what we hope for when we're finding the derivative of a polynomial. So we'll put that business together, and we'll have the limit as h approaches 0 of h outside of 3h plus 6 all over h. They'll cancel out. And if we let h approach 0, what we'll find out here is that our limit is 3 times 0 plus 6, or just 6. So the slope of this tangent line when x equals 1 will be 6. All right, so let's get our tangent line first then. So to get our tangent line, my equation, as we saw before, is y equals f prime of a, which in this case is 1, times x minus a, again it's 1, plus f of a, which is 1. So this will be y equals 6 by x minus 1 plus 5. And that's the equation of the line. Some folks would prefer to have that simplified. I certainly think that's an acceptable answer. But if you want to simplify it, you could call it 6x minus 6 plus 5, or 6x minus 1. And there's the equation of your tangent line. Okay? For the normal line, it's going to look exactly like this, except we have to change one little detail, and that is our slope right here. So for our normal line now, so let's get the equation of our normal. It will be y equals negative 1/6 of x minus 1 plus 5. Okay, so I would accept that answer left that way, but if you want to be a little more concise, minus 1/6 of x plus 1/6 plus 5, and if you want to write that with a common denominator, you could have y equals minus 1/6 of x, and then 1/6 plus 36 is a 31 over 6. So you could write it that way. So everything has a nice denominator of 6, but there's the equation of your normal line. So that's a pretty straightforward process. As long as you stick to that formula and you're quite comfortable with the part where you have to find the derivative, there's not a whole lot to this. It's just remembering what it means. All right, so we're going to jump right into the your turn question because there's not a whole lot to this stuff. So enjoy the your turn question there. You got to find the derivative of f of x at x equals 11, and then after you find your derivative, you need to know the coordinates of the point of tangency, remember? And if you get all that put together, you can find the equations of both the normal and the tangent lines. Okay? So now I'll put up a solution for that. If you want to pause and go work through it, by all means do so. And here is the solution. So over here we've highlighted how we found the derivative, and then found the coordinates of the point of tangency. And there's the slope of the tangent and the slope of the normal. And these are the two equations that we're looking for. All right, let's highlight some of the key features here. So some of the stuff we talked about, we say there are two important things to know in order to get the equation of a tangent or a normal. The point of tangency, so we've got to have a point, and we need to have a slope, which is the value of the derivative f prime of a. So the equation of the normal line and the equation of the tangent line, and wowee, look at that, I mixed them up again. So let's make sure we get that clear before I go any further here. The equation of the tangent line is this one, and the equation of the normal line is this one. So this one is the tangent, and this one is the normal. Okay? So I hope that's helpful. I hope your studying is going well. All the best on your exams.